AI can write code. It can build websites. It can generate unit tests. It can explain APIs. It can solve coding problems. It can even build entire applications. And because of that, many people are asking, will AI replace software engineers? I work as a software engineer at a FANG company, and after years of helping build and operate large-scale enterprise systems, I've come to a conclusion that may surprise you. Coding was never the hardest part of software engineering. And if coding was never the hardest part, then AI writing code doesn't automatically mean AI replaces engineers. The real question is, what do software engineers actually get paid for? If you're a junior engineer, AI can feel terrifying. You open ChatGPT, Cloud, or whatever AI agent you're using, client, you paste in a problem. In seconds, you get code. You watch AI build applications on YouTube, or even you've built one for yourself. You see headlines saying developers are finished. Coding is dead. AI will replace engineers. And if your understanding of software engineering is engineers write code, then the fear makes perfect sense, because AI is becoming incredibly good at writing code. But writing code is only one layer of engineering. Let me kind of explain it with an engineering pyramid. Bottom is writing code. Above that, we have implementation decisions. Above that, you have system designs. And above that, you have to think of trade-offs even before you get to the system designs. And to get to the trade-offs, above that, you have business understanding. And to get business understanding, first you have to go above, which is problem definition. And at the very top is even deciding what should exist in the first place. Now, for years, engineers differentiated themselves by how quickly they could move at the lower levels. But AI is rapidly climbing upward, and engineers must move upward faster. When people imagine software engineering, they imagine someone sitting alone writing code. That has really been my experience working in Amazon in a FANG company. Over the years, I've spent time helping design systems, reviewing designs, investigating problems, understanding constraints, aligning with other teams, and figuring out how to solve business problems. Many times, the coding itself took less than the time to arrive at a decision. I've spent days discussing who owns the problem, which service should change, which team is responsible, what risks exist, what trade-offs are acceptable, whether we should build something at all. And after weeks of discussions, alignment, and design reviews, the implementation might take only a few days. Now, the higher you go in the ladder, the less your job becomes writing code, and the more your job becomes reducing ambiguity. Suppose someone says, build me a program that adds 2 numbers. Looks simple. You can give the problem to AI, and AI can write that instantly. A junior engineer might immediately begin coding, or at least give prompt to AI to write the solution. But experienced engineers begin asking questions. What kinds of numbers? Integers, decimals, very large numbers? Where does the input come from? Is it an API? Is it a file? A web page? Another service? How many requests? Who uses it? What happens when input is invalid? Should requests be logged? What are the security requirements? What are the latency requirements? What are the cost constraints? You notice something? The difficulty was never addition. The difficulty was understanding what problem actually needed to be solved. And this is where engineering value lives. Like I said, the higher you go up in a chain, the more ambiguous the problems become. Junior engineers often receive well-defined tasks, existing designs, clear requirements. Their primary question is, how do I build this? Senior engineers, they ask, what exactly are we building? They are questioning, asking all these questions to unravel exactly what needs to be built. Now, principal engineers, they ask, should this even exist? So as engineers grow, They spend less time solving technical problems, or at least only technical problems, and more time solving ambiguous problems. And ambiguity is difficult. There is only incomplete information, conflicting priorities, changing requirements, and trade-offs. You can't give AI incomplete information and expect it to give you a solution that is optimal. And this is why senior engineers earn more. Not because they type faster, but because they understand uncertainty. Many engineers believe if AI writes code, engineers disappear. But that assumes the value of engineers is writing code. If your entire value is I can implement features faster than other people, then AI should concern you because AI is becoming very good at implementation. But if your value is understanding customers, understanding systems, understanding trade-offs, understanding constraints, understanding organizations, then AI becomes a multiplier, not a replacement. AI is excellent at writing code, generating tests, explaining APIs, refactoring, writing documentation, creating examples, boilerplates. You can even use it to help design solutions. I use AI. Many engineers use AI. Entire teams will use AI. The productivity improvements are real. AI allows us to move faster. But notice something? Most of these activities answer the question, how do I build this? AI excels at the how. Where AI still struggles is undefined problems, organizational context, team dynamics, historical decisions, competing priorities, business constraints, stakeholder disagreements. You need people to gather that. Consider questions like, which team should own this? What is the least risky solution? Which trade-off is acceptable? What does the customer actually want? Is this even worth building? What happens 6 months from now? These answers often exist in people, in organizations, in business context, in conversations, in experience, and that is where many senior engineers spend most of their time. At Amazon, I spend time reviewing designs, discussing requirements, creating designs also discussing trade-offs, clarifying ownership boundaries, aligning with teams, aligning requirements. Only after you've done that, after you've gathered all this context, then you've designed, you've reviewed with the teams, you've reviewed with stakeholders, then the coding comes into the picture. The difficult part was determining the right thing to build, not in building it. This is the reality of many large systems. The software often isn't the hardest problem. The decisions are. 20 years ago, or even a year ago, being able to write code quickly was a significant advantage. Today, AI can generate code faster than all of us. AI improves, value moves upward. The valuable engineer becomes the engineer who can understand problems, clarify requirements, design systems, evaluate trade-offs, communicate effectively, understand customers, align teams, make decisions. AI increasingly handles portions of implementation. Human increasingly define the problem. If you're new to engineering, this should not discourage you. It should guide you. Continue learning the basics, the algorithms, the programming, how to design systems, but also learn communication, product thinking, architecture, trade-offs, requirements gathering, business context. Ask questions such as, why are we building this? Who benefits? What alternatives exist? What constraints matter? What happens if we do nothing? Those questions accelerate your growth. The engineers who thrive in the AI era won't necessarily be the engineers who write the most code. They will be the engineers who understand problems deeply enough to know what to build, what matters, what success looks like, what the trade-off. They will use AI, they will move faster, they will automate implementation, but they will still provide the judgment that software systems require. Coding was never the hardest part of software engineering. In other words, the how wasn't the hardest part. It is the what that is the hardest part. And that's where most senior engineers spend their time.